Here's the second part of the video for learning target 5.7, where we've got this example that says that a regular hexagon is inscribed in a circle with diameter of 7.52 centimeters. And it wants us to find the apothem. So, to remind you back from geometry, the apothem of a regular polygon, whether it's a hexagon or a heptagon, goes from the center of that polygon perpendicular, so it meets it at a 90-degree angle, to the midpoint of any one of the sides. So the apothem could have been drawn right there. And as long as it meets one of the sides, that would be the apothem. So you'll notice it's a little bit shorter than the radius of the circle, because the radius of the circle would go all the way out to the edge. Okay, so how are we going to find that length? Well, it tells us that the diameter is 7.52. So if we look at the diameter of the circle going all the way across, I know that that's 7.52. Which doesn't really help us a whole ton. But if we make the diameter go from this corner to this corner, now we've got something that's going to help us out. Okay? Because it doesn't matter where in the circle I draw that diameter has to be 7.52 centimeters. Okay? Now I mentioned before that the apothem has to meet one of those sides at a 90-degree angle, so now we've got our right triangle. And I know that this side right here is the radius of the circle. Because it goes from the center out to the edge, I can label that radius of the circle as half of 7.52, which is 3.76 centimeters. Okay, so now we have to figure out how we can use that to find the apothem. Well, we only know one piece of information in that triangle. I only know one side. And when you go back and you're using those formulas, you need to have one angle and two sides to be able to use trig. So we either need to know one of these two angles, or we need to be able to find the length of that third side. Okay. So let's see if we can figure out how big this angle is. Well, it's half of that original angle of the hexagon, so if we know how big each of these angles is in that hexagon, then we can figure out that this angle right here is just half of that. Okay, so you might have to do some scratch work. There was a formula that you learned, but maybe you can say, okay, well, triangles have 180 degrees, and quadrilaterals have 360 degrees. What about pentagons? Pentagons have 5 sides, and if the pattern is always adding 180, then pentagons have 540 degrees. So how about our hexagon? Our hexagon, we can add another 180, and we get 720 degrees. Okay, so that hexagon has 720 degrees. If we want to figure out how big each one of these angles is in that original hexagon, we can do 720 and divide it by 6, and that tells us that each one of those original angles is 120 degrees. Okay, so if we label that in here and we say, well, this angle is 120 degrees, this is 120, okay, that means that this angle is 120 degrees up here. But we don't have the whole angle, we only have half of it, so we can say that, where are we here? If this is 120, this part right here is going to be 60 degrees. I already know that that's 90, which tells me that that's 30 degrees. Okay. Another way that you could think about it, just giving you some strategies, is to try to figure out how big this angle is first. Okay. So if you want to draw in all of these diagonals, got a full 360 degrees right there. It's divided up into 6 equal pieces. So each one of those is 60 degrees, 60 degrees, 60 degrees, which means that's 60 degrees. So half of it would be 30 and the other half would be 30. So either way you want to think about it. Let's see if we can get rid of that and that. we just need that this was 30, this was 60, and this was 90, which is also one of those special right triangles. And then I have to add back in that this is at 3.76 centimeters. Okay, so now we've got a couple of options. We can decide which one of those angles we want to use. So let's just say I pick the 30-degree angle. Now I can label the apothem as adjacent, and has 3.76 as my hypotenuse because it's across from the 90-degree angle. So now, knowing that I need to use the adjacent side and the hypotenuse, I can set up my trig function, and I'm going to have to set up cosine. So cosine of my angle, remember I chose that 30-degree angle, is adjacent A over the hypotenuse 3.76 centimeters. So now we're solving for A. We have to get rid of multiplying by 3.76. So it cancels. Multiply this side by 3.76. If you type all that into your calculator, we get A is approximately 3.26 centimeters. Okay. Which seems right again. We mentioned that the apothem was a little bit shorter than the radius because it doesn't quite reach out all the way to the end. So 3.26, about half a centimeter short of the radius. I'd say that looks about right. And the last thing that I just want to mention is the note at the bottom of the page, talking about angles of elevation and angles of depression. And this is something that's set up oftentimes in word problems. So it will describe the angle of elevation as a certain number of degrees or radians. And it's important here that it's always measured to the horizontal. So horizontal looking up, that's my angle of elevation. Horizontal looking down is the angle of depression. So I'll give you an example of what a lot of people do incorrectly. Is there might be a word problem that says there's a building, and from the top of the building, the angle of elevation, maybe there's something down here on the ground, and it says the angle of, or sorry, not the angle of elevation, the angle of depression from this point down to a point on the ground is 40 degrees. And people will say, well, that angle of depression is 40 degrees, so they label it right there. But even if it's not already drawn in the drawing, you always have to say the angle of depression goes from horizontal looking down. That would be the 40-degree angle, not this one in here. So remember, angle of elevation and angle of depression are always from the horizontal looking up or from the horizontal looking down. Okay, that is it.